Autodesk Integrated CAM for SolidWorks. Before we get into the demo part, I'm just going to go through a few slides to kind of give a background and why Integrated CAM should be chosen. So first we'll start with basically the owner of HSMWorks, Autodesk. Autodesk is a world leader in 3D design, engineering, and manufacturing. And since the introduction of AutoCAD more than 25 years ago, they've been setting the standard for design and engineering. Their portfolio is the largest and deepest in the industry. They've got over 10 million users and at over 800,000 companies. But in this, Autodesk believes in streamlining workflows and leveraging digital prototyping experiences. They want to be able to take a single data file from concept through manufacturing. So let's focus on the last part of the workflow on the manufacturing end. So since Autodesk has purchased HSMWorks, they've been able to better HSMWorks and also add 2 more CAM solutions into their portfolio with Inventor HSM and CAM 360, which is the first cloud-based CAD/CAM solution. So why Integrated CAM? Integrated CAM, you're able to leverage your existing investment in CAD tools, but also add in the the ability to add CAM to those CAD tools. And because of this, the typical 8-step machining process, and of course the 16-step machining process where an ECO is involved, is greatly reduced when the CAD data is leveraged. So by reducing the steps to updating CAD data, regenerating and validating toolpaths, and posting your code, it allows the NC programmer and design engineer to take control of the NC programming process. And many downstream benefits include ETO automation, streamlining of communications, true workgroup collaboration, ETO accuracy, and faster turnaround time. And there are a lot of players in the integrated CAM space, and Autodesk focused on just one, HSMWorks. And this is because HSMWorks founders shared an innovative vision that Autodesk has. So when you consider major advancements in CAM industry, you will find an HSMWorks founder behind them, including the birth of adaptive clearing, which became the basis to which HSM, high-speed machining, was built upon. And a lot of first-to-market options, both technological advancements like distributed CAM and the first ever CAD/CAM cloud option, and business benefits such as a free post library, open API, and flexible purchasing options to meet the nuances of each type of company. So with that, there are 3 primary flavors of HSMWorks. First, you have Express, which is our 2.5 axis milling option. You have Professional, which is Express plus your 3D milling, 3+2 and 4 axis, turning and mill turn, and then our Premium option, which is multi-axis milling. So including an open API, access to more than 75 post-processors, adaptive clearing, and tool libraries, the product levels are not modularized. They also allow you to leverage integrated CAM regardless of your budget and machining needs. And in the case of our standard and professional versions, you will need to have your own seat of SolidWorks. So as you can see, there are lots of features that are included in these options. So here are a couple examples of companies around the world that have integrated their CAM with HSMWorks. So now with that, let's go ahead and go into our demo side of the presentation. So first off, I want to start off with just showing our 2.5 axis. And just show you how easy it is to get a program done. So first what I want to do is I'm going to create my job setup. So notice it originally finds my model. And then here I have the ability to select how I want to define my stock. So we have 5 options. For this one, second solid body in my part that I want to define as my stock. So with that, I can go ahead and OK, and now I can start milling this part. So first, I'm going to start off with a face toolpath. I go to my tool library, pick my face end mill, and here I have to hit OK. That's all I do, and it finds the part that it needs to mill and knows what it needs to take off, and it defines the toolpath. So next, I want to go ahead and start roughing out these pockets. So I'm going to go to my 2D adaptive clearing. Again, go into my tool library and pick my 1/4 inch flat end mill. And then here, I'm going to pick the bottom face of my pockets. And if I wanted to, I can go to my passes tab and tell it how I want to do my stock to leave. I'm going to leave that as it is. And here I'm going to hit OK. So now I've got my pockets roughed out. And now I want to rough out the outside of my part. So I can right-click on my 2D adaptive, and I can click Duplicate. And if I go in and edit this, in my Geometry tab, I can clear the selection from the previous operation. And now I can define my selection for this operation. Now, one thing I want to note is this checkbox down here for machine cavities. I'm going to turn that off so that it knows it's going to be milling between the stock perimeter and this part, or in this contour. So again, hit OK. And now I've got the outside of my part roughed out. So now let's say I want to go in and start doing finishing passes on this and on the outside. Again, I can right click on my 2D adaptive for the pocket, and I can go to create derived operation, and then to 2D milling and 2D pocket. So with this, it's got all the same settings as was done in the first adaptive clearing operation. So here, all I need to do is turn off stock to leave. And again, I can do the same steps to finishing the outside of my part with 2D contour. And here, the stock to leave needs to be turned off as well. So now we've got a roughed and finished pockets and outside of part. So what we want to do next is I want to go and chamfer the outside and then in each of these pockets. So with that, I'm going to do a 2D milling operation, 2D contour. Again, I'm going to go into my tool library, and I'm going to pick my chamfer tool. So here I can pick that contour, that contour, there and there. So now, one thing I want to show you is on my passes tab, now that I've picked an actual chamfer bit, you'll notice I have an option here for settings in my chamfer operation. So one thing you want to know is with HSMWorks, they built this to where it doesn't clutter your user interface. It only shows the options that you need for the operations and tools that you're using. So here I want to set a 0.05 offset down in the tool bit so that I make sure that the cutting surface is completely touching the part. Okay. So we've got that, and now I just want to do a simulation, and so we can see basically where we're at. So one thing you want to notice in these simulations is not only does it give you toolpath information on XYZ movements, you also get operation information. So telling you what operation is and the tool I'm using. And then it's also giving you machining time. So we know that we've got the part rough, and the last we got to do is our holes. And here we need to do a pre-drill with our tap. So the first thing I'm going to do is go to my drilling operation, and I want to do a spot drill. So I've got my chamfer bit selected already from the last operation. I'm going to keep my chamfer. And all I need to do is click on the conical face, and then come over to my browser and select same diameter. So you notice now that it's found all those holes. So I didn't have to go and select them all. And then it's giving me a warning saying that a non-drill bit has been selected for a drilling operation, which we all know you can use a chamfer bit for a spot drill. So we're just going to go ahead and say yes and ignore that. So now I'm going to go back in, and I'm going to do my drill. I'm going to tilt it down to where I can see the smaller diameter. Again, here I want to select same diameter and auto merge. And the auto merge basically tells it to find, say, hey, there's more geometry above, so you need to make sure you compensate for that. So now I've got that. And then lastly, I'm going to do my drill, or my tap. Again, I select same diameter and auto merge just to make sure. Okay, so with that, we've got a programmed 2.5 axis part. Now, let's say this isn't just an individual part, you're doing this in assembly. Okay, so I've got two fixtures, two of these parts, and then the same part flipped over so that you can mill the bottom. So I've got this first part already programmed. Now one thing I want to do is I need to recreate all these toolpaths over on this part. But I don't want to go and just have to redo everything. So I'm going to select all my toolpaths, and I'm going to say make pattern. Now one of the great things that I like about HSMWorks is if you have multiple parts of the same part, we have component pattern. So all I have to do is pick my components, and it automatically finds the part. And then it doesn't matter where that thing is. I can do a drag and create multiple copies. Anyway, and it'll find that part no matter where you put it. So now let's say I've got my job set up for this part, and I want to use some of these toolpaths that are in this on this job setup above. So let's take this face operation at first. I can right-click on it, and I want to copy it, and I want to paste it into this folder for this setup over here. So now all I have to do is hit Generate Toolpath, and it'll automatically find and set it on that new geometry. But now, I've got this 2D adaptive operation for these pockets. I want to use the same operation with tools, settings, everything, and I don't want to have to go recreate it or copy and paste. One of the things that is awesome in HSMWorks, I can click a face, and I just drag and drop. If I had the right folder set up. Let's try that again. Drag and drop. And there you go. And so I can do the same thing with the pocket operation. So there's some pretty awesome ways of copying and pasting toolpaths and patterning components. So next, I want to go ahead and go into our 3-axis part of the demonstration. So before in our 2.5 axis, we had to define some of the geometry and where it was going to lay at. But in our 3.5, or in our 3-axis, we don't have to do that. So what I want to do is I'm going to come in, create my setup again. This time on my stock, I'm just going to say relative, and I don't want to have any additional stock. Okay, and then I'm just going to click OK on that. So I've already got my setup. So what I want to do is in my 3D milling tab, I want to go down to adaptive clearing. And my first operation, I'm going to do a 3/8" full nose end mill to just rough out some of the material. So with that, I'm just going to click OK and let it go. So while that's going, I'm going to go ahead and start my other adaptive, and this will be more of another roughing step down from that one. So I'm going to go on my 3/16 full nose, and in my geometry tab, I want to change my rest machining option from previous operation so that it recognizes what's been removed in that initial adaptive that we did. And so notice while I went in and created this adaptive operation, my first one finished doing its calculation. So while that one's going, I'm going to go in and I'm going to finish off the top of this little flat face right down here. So I'm going to do my horizontal operation. I'm going to keep the same tool. And then I want to go ahead and OK and see what I get. So while I was doing the horizontal, again, my second adaptive clearing finished. So with this horizontal now, it found not only the face at the bottom where I'm wanting to go, but it also found these two faces at the top, which obviously I don't want to do because it's already finished. So let's go ahead and hit edit. I'll go into my height tab, and I'm going to change my top height tab to be just below that so it doesn't recognize it. And so now that's finished. So we've got this roughed out. This face is finished. Let's go ahead and simulate this a little bit and see what we get. So again, down here you can see in the statistics, it's estimating my machining time to be 31 minutes. All right. Now, another great feature to show in the simulation is comparing stock to the model. So you can see we've got quite a bit of material that we still need to remove to be able to have a finished part. So let's go ahead and start doing that. So in my 3D milling, I'm going to go into my parallel command. And for this one, I'm going to go down to a 1/4" ball nose end mill. Now, if I go into my geometry tab, here I want to do a slope containment of my toolpath. So I want to do 0 to 35 degrees. And then I'm going to go ahead and hit OK on that. Okay, so now notice, again, it got the top face on both sides and the top face of this. And I really want to refine my step over, and I want to change my direction, my path direction. So let's go ahead and go back in here. So again, in my geometry tab, I want to go ahead and turn off, make it to where it avoids these two top surfaces and then this surface as well. So I'm going to turn on my check surfaces. and I'm going to select those three faces. Now, for the step overs, I'm going to go into my passive tab, or my passive tab. I'm going to change this to 0.02. And then for my pass angle, I'm going to go to a 45-degree angle. So now you'll notice I've got a really fine step over now. It's angled at 45, and it's contained in that 0 to 35-degree angle. So now let's go ahead and get the rest of it up. For that, I'm going to do a contour. And on my slope, I'm going to make a 30-degree slope to 90 degrees because I want to have that 5-degree overlap to make sure that I get all the material. And then I'm just going to go ahead and hit OK. Alright, so now you'll notice not only did it get the inside, but it also got the outside. And we don't want that. So let's go back into that. And on my machine boundary, change tool to outside to tool center. And go ahead and hit OK. So now it looks like the toolpath that I want for that. So let's go ahead and simulate this again on the stock simulate. And I'm going to go ahead and speed it up so we can get that comparison window to see what we got left. Alright, so simulation's done. Now let's go ahead and turn on compare. So now you'll notice what I got left are there's material in these radiuses. And that's about it. So let's go ahead and do one more toolpath and see if we can finish that off. So in my 3D milling panel, I'm going to go down to pencil toolpath. Now for this one, I'm going to do a 16th inch ball nose end mill. And I'm going to click OK. Alright, so you'll notice it got these smaller radiuses and then this radius down here, but it didn't pick up these larger radiuses. So let's go back into the toolpath. And over my passive tab, I'm going to change my over thickness to 0.125 so it'll find the larger radiuses. I'm going to change my step over number to 4 so that I can limit the number of step overs it takes. And then I'm going to do 0.02. I'm going to click OK. And now you'll notice it picked up all these larger radiuses. And now, if we do a stock simulation, and you'll notice that each toolpath is also color-coded as well, which corresponds down to the bar at the bottom showing you where each step is. Alright, so now we can do a comparison between the model and the stock. It looks like we have a good, complete part. So that's 3-axis. Next, I want to go into a little bit of 3+2 just to kind of show you, what exactly you can do. So you'll notice that all these toolpaths, this whole part was programmed with my 3D milling toolpath. So let's show this one. So one thing you can do is you define your tool orientation. And then here I defined how far down I wanted that tool to go so that I knew that my tool would be able to go down without any collision between the shaft of the tool or the holder on the part. And then also, a lot of these were done with, let's do this one. We're done with creating a sketch. So by creating a sketch, I'm defining the boundary in which I want my tool to go so that it stays within that boundary at the plane depth that I set in my toolpath. So this is a good, easy way to be able to machine parts that you think would be a simultaneous 5-axis on a 3+2 and be able to have a complete finished part that looks really good. So here's an example of where I use that sketch boundary and then modify depth in which I wanted my tool to go. And then that flow was just being able to finish that part. So I want to do a simulation of this real quick so you can kind of see the tool in motion and how it changes the orientation. So there I have, that's my first pass with the adaptive. Here's the second pass on the adaptive. Basically, I'm just roughing out the part. So now it's going to start going into the scallops and doing finishing passes. In a second, right here. So that's an example of how you can do 3+2 milling with where a 5-axis simultaneous doesn't need to be completely used. Now I want to show, whenever you get into the 5-axis, how the way the HSMWorks has done it, they've added basically multi-axis tilting capabilities in the 3-axis tool options. So this would be normal contour that we would do. You select the face of the geometry that you wanted to go around, and then that would be it. But if I go in and simulate this in my stock, you'll notice over here that I'm getting clashes with the holder and the shaft. So to get by that, I can do what's in HSMWorks a shaft and holder detection, basically. And so with that, we've got multiple different options that you can do on how the toolpath would react whenever it detects a collision. So as you can see, I can either do a trimmed option, a pull away, detect tool length, or just fail the toolpath completely on collision. So in this one, we did trim. And so what you'll see is that it literally stops the toolpath at the point that it detects that there's going to be a collision. But where does that leave me on machining the rest of my part? So what we can do is, I'm still having my shaft and holder detection, but if I go into my passes tab, I have the option to turn on multi-axis tilting. So I've got that turned on. I've got it set to an overall of 90 degrees to be able to move in, and 5 degrees front and back. So if I go ahead and simulate this, you'll notice as it goes around, it's tilting to make sure that the shaft and the holder stay away from the actual stock of the part. So again, here I can do that on this machining off this face. You know, this would be the option without the shaft and holder. So this would be with trimmed turned on. So it's pulling up, retracting to miss this part of this material, and then retracting over on this other side as well. And then here again, I've got my multi-axis tilting turned on. Again, in the passive tab. And so here I'm able to see that once it gets to that point, it will tilt. It will tilt if I have the right option turned on. Okay. And then the same can be done on the pencil operation. So with that, let's show a little bit of how you can do a simultaneous 5-axis operation. So again, this part is mostly programmed with our 3D milling options with the drill. And you'll notice that these are also circular patterns. So if I go in and edit this pattern, I've created the one operation where I've oriented the tool. Which is this initial drilling operation. And then I've selected the circular pattern, pick the face, and then tell it how many instances I want. So down here I've done the same thing. I've got this flow operation set up to finish off this contour, and then I've got the second flow operation to do finishing pass on this contour. And then my swarf, which is a multi-axis milling option right here, is doing this angled contour right here. So then let's say do a stock simulation on this. And so one of the things I want to mention too is that in your tool library, whenever you create tools or use other tools, you have the option to either have a tool holder on there, which you'll notice the first tool didn't have a holder, or you can have one selected, or you can create your own when creating your library. That's one of the good things. There's multiple ways to create tools. You can create them through their standard dialog boxes, or you can actually model your own and insert it as a form tool, which is pretty handy when you have custom tooling. And there again, you can do the same thing with the holders. You can use their standard ones and then basically copy the design and modify the geometry per what you need for your holders in your company. Alright, almost done. Alright, so that's the 5-axis simultaneous show. And so one other thing that you can do in here, and this one is, you can do machine simulations. So let's just say I want to go ahead and simulate that on a machine. I right-click on my job and go down to Machine Simulate. Well, let's say I just want to hide some of the housing so I can make sure I've got all my so I can see how it's actually running. I'm going to go back in my CAM tab, simulate. Alright, let's go ahead and watch this. So it's pretty nice to be able to do machine simulations and watch the actual operation. So here you can actually see whether you're going to have some kind of collision as well in your toolpath. Plus it's just kind of fun to watch. Want to get into the tilting. Okay. So now I'm going to go ahead and go to the mill turn and turning aspect of it so you guys can see kind of the basics of how it works in here. So I've got my part. Again, I'm going to create a job setup. Now the one difference between milling and the mill turn option is that I actually have to define a different job type. So again, my model's been selected. I'm going to go to a cylindrical stock, and then I'm going to just pick a face so that it knows that's where it's going to be centered at. Now you'll notice that it kind of has invisible lines, not really invisible, but dashed lines representing the chuck. You can define and model your own chucks and then select it here. And I know a lot of people do that as well. So I'm just going to kind of set up some of what my stock option is going to be. Change to 0.3. I'm going to do 0.1 on the front end, 0.1 regularly. Okay. I'm going to go ahead and click OK. Now, to start this, I'm going to do a turn-facing operation. Go into my tool library. I'm going to use this diamond tool. Then I'm going to go ahead and click OK. Now you'll notice that the tool goes home before it goes into the part. Now you can change that right here on the front. I'm going to say don't go home. And then it's right there. So next I'm going to go ahead and rough down the profile and use the same tool. And here I just want to go ahead and click OK, see what I get. Alright, so you'll notice that with that operation, it's gone down at an angle. But say I didn't want to do that. I wanted to save that for whenever I do my profile grooving. And I just wanted it to come straight across. I can go into my toolpath And in my Paths tab, I can turn off Allow Grooving. So now you get a straight shot across, and then whenever I go in to do my profile grooving, it's the stock is straight across instead of being at a different level. But I want to go ahead and turn that back on in this case. So now if I go in and do a turning profile groove, I'm going to select a different tool. So now you'll notice that it's already noticed that my previous operation has got it down to this. And I've already got finished over here. So I basically want to contain my toolpath between here and here. So with that, what I want to do is go to my Geometry tab and turn on Confinement. So to confine that, all I have to do is pick my two edges that I want to confine it within. So now you'll notice that this containment box is now just reduced down to that spot that I want. So with that, I'm going to go ahead and click OK. And now I've got a rough and finished edge. As you'll notice in my Geometry, or my Paths tab, I've got Finishing Paths turned on. So we'll go ahead and simulate this and see what we get. Okay, so you can see that I've got a good finished part. Now I just need to part it off. So here I'm going to do in turning part, and you'll notice it's already recognized where it needs to go. And so with that, all I have to do is click OK. And that is that for that part. Now I want to show the option of doing mill turn. So again, your setup's the same. I've defined my job type as turning or mill turn. My model has been picked, and then I've selected cylindrical stock. Now, in this one, what I've done is, if I go in and do a turning profile, you'll notice that the geometry it selects isn't the entire part. So what I have to do is, in my Geometry tab, I go in, I need to select an actual model that would encompass the whole part cylindrically. So I've created a second solid body that doesn't have any cutouts or anything that will represent the part that needs to be milled to. And so you'll notice already that the boundary of what was going to be milled has already updated for my new geometry. So I'm going to go ahead and click OK. Obviously, I have to pick a tool. Now I can click OK, and I've got that. So I've got that rough and finished. And then what I want to do now is, let's say I want to go in and I want to mill out these little slots. So I'm going to pick 3D milling, 3D adaptive. And what I want to do is take my 1/4 inch flat in my tool library. And here I want to go in and I want to select that face as my stock contour. And then I also want to pick it as my machining boundary. And then I want to come down to the bottom here. And I want to do my tool orientation to that face. And then again on my rest machining, I'm going to change from job stock to previous operation. I'm going to go ahead and click OK on that. And now you'll see that I've got a milled out portion of that part. So now I want to go ahead and do a circular pattern of that operation to be able to get the rest of them. So I want to go pattern, circular, pick the cylindrical surface, and then I'll put in my number of instances, and there it is. Now, in doing this, I can either say preserve order, order by operation, order by tool. Those would come into play if you're doing multiple operations with multiple different tools. But in this case, we're just doing one. So, and there's that. Now I can do the same 3D milling adaptive. Pick that as my machining boundary. Clear that selection, and now I'm going to pick this face as my tool orientation. And then I also want to select this face so I can get both those at the same time. Click OK, and there it is. Now the one thing I noticed is at the very beginning I didn't do a turn face operation. So let's say I need to go back and do that real quick. I'm just going to do a turn face. Again, here I'm going to go in and I'm going to select my model as that just to make sure it does it right. Go into my tool library, pick my tool, click OK, and it's there. But it's inside that folder operation, and I need it at the beginning, so I'm just going to drag and drop it. I can generate all these other toolpaths. So now you'll notice that these toolpaths, because you gotta change first machine previous operation. So now you notice all the toolpaths have updated to show that it sees that the face has been turned, and now it's updated for just doing those buttons. All right. So that sums up the actual programming part of it. Now let's go back and look at this option again. And what I want to do is delete that one. Now it's going to have to update all these. So now it's finding just the two parts again. And I want to go in and post-process this job. So let's say I'm just going to use generic cost post. And then what you'll notice in here is that there's a lot of different pre-built-in properties that you can change. For instance, you can turn on and off homing at the end of the job. Preloading tools, your G187 for your look-aheads, G0, G28. If you use subroutines, you can turn that on here. And then these are options that are built in, and then ones that are programmed in your post-processor. So I'm going to go ahead and post with that one. And so this is what will come out for your HOS post. Now, I believe that this NC editor is one of the best ones out there for just being able to visually see how your toolpath is going to react through the code in your machine. So what this one does is I can simulate these line codes And if you'll notice in the left browser, it follows along with it. So if I wanted to, I could pause it here and say, I want to make a change to that, somewhere in that line. And then I can just keep going and it'll just change. And then all I'd have to do if I made that change, I just go up here and hit save, and I'm good to go. Some other things that you're able to do in here is, this is also the point that you would, if you had multiple work offsets, you could define the distances between them. I can send my NC file from here to a machine through the DNC. I can even compare files. So if I had a file at a machine and I had to make modification to it, I can send it back here. I can compare what I originally posted with what was changed with the machine through the file compare. And then there's other just basic NC functions, modifications that you can do. So that concludes my aspect of this web event. Back to you, Ted.
Matthew, thank you. Thank you. And now I'm getting feedback. I hope nobody else is. Thanks again, Matthew. It was very detailed. These 1-hour presentations, it's tough to cover everything, but Matthew did a wonderful job. If you have an interest in this, we would love to engage with you and your company specifically. We can show you more, talk to you about it, and we're standing by and ready to do so. The questions pane was quiet. I think you did a great job of probably answering a lot of questions right through the presentation. So I'm not saying any questions come in. If you think of questions after the fact, don't hesitate to let us know. Again, we want to engage with you and make sure that the solution is right. But since the question pane is empty, this will then conclude our broadcast. If you do have any additional questions, reply to the confirmation or reminder email that you received from GoToWebinar, and we can route those to the appropriate parties. As a reminder, you will be receiving an email containing a link to the recording. And if you'd like to if you can take a few minutes to answer the short survey at the end, we sure would appreciate. The survey will automatically appear when you close this session. And the question pane is still empty, so it's lunch for some people. I know some of you may be eating lunch, and we appreciate you taking the time out of your day to sit in on this with us. So I'll thank you for attending today's webcast, and we'll sign off, and I wish you all a very good day. Thank you very much.